Welcome back again to part 9. Last time in Minecraft's most stable mod, Create crashed my game 9 times in a row, nearly ending the playthrough before I fixed it and made infinite rubber, aluminum, silicon, sulfur, oxygen, and iron. This was used to burn 2 whole hours slowly smelting Kanthal to get the silicon needed in transistors, which I used to make my first HV circuits and this steel boiler. At the end of last episode, though, I said I would spend this episode climbing to reach AE2, which allows you to store items in a computer and will need a lot of progression to reach. So without further ado, let's continue. Okay, so I said at the end of last episode that this would be dedicated to getting to AE2, and AE2 is going to be horrible to get to. In fact, we might end up with another hour-long episode, because we need titanium. Titanium really isn't that bad to smelt, because we actually already have a good enough EBF, and this titanium dust we can get from the centrifuge with gabbro dust, though I can make another factory for that. And that'll be also an extra source of iron, because this system is less than ideal. Speaking of which, it's not running right now. So titanium dust is not hard to get, but it makes hot ingots. And this specific kind of hot ingot needs a vacuum freezer, which needs EV circuits. And that is a whole huge rabbit hole. We're gonna need a clean room, we're gonna need microprocessors, blue alloy, I didn't even see this. It's a massive... Please help me. It's a huge rabbit hole to go down, but I think the first place we can start at are those microprocessors. Microprocessors can be made at MV tier, meaning there's no upgrading from LV, and we've done all of the groundwork for this already, with transistors and capacitors which need plastic circuit boards, all of that. CPU chips are also pretty easy since we already have the diamonds for that. So the only real problem is that we need an MV circuit assembler which needs some of its own HV circuits. So to start off this episode, I'm going to make 16 MV circuits and turn half of those into HV circuits. I'm going to start overcrafting things a lot more. Overcrafting is better because then you don't have to craft later. Makes everything a lot faster. Like this iron. I have so much now. And I'm making a bunch of steel for absolutely no reason. Not sure if I gave this diorite factory enough screen time, but it is actually insane how much stuff I'm getting out of this. Just look at this. The factory's only been running for like half the time I've actually owned it, and this chest is full. I am gonna get some super chests, like I've promised with everything, but the LV circuits have made that a little bit unappealing. Okay, so 32 tin bolts, 32 fine wire, 32 resistors, 16 IC chips, 16 resin printed circuit boards, and 32 diodes. That's a bit annoying. Yeah, last episode didn't actually have a lot of circuit recipes, or at least it may look like that to you guys, but that was probably the most circuit-filled episode of the whole series. I made maybe a total of 64 integrated circuits because of all of these factories I'm making and the HV circuits required in there. It's just that that's incredibly boring. Like, I didn't show even a single one of those. By the way, I just finished editing yesterday. This is the day after releasing the video. But this time I can just show a little bit of the process because at least I'm talking through it. Oh, I don't think I have enough iron 3 chloride for that. Yeah, I'm 100 millibuckets short. I'll need, for this recipe, 64 silver foil, which is what I'm doing in here. I don't like setting the bender on 10 because I always forget later. Okay, there's our printed PCBs. And this thing should be done at least one of the boules, so I can cut that up, and that will be 16 wafers, which we can turn into diodes. Okay, so if I put enough plastic in there, this should be making a stack of diodes. And now that we're making these diodes, I can start crafting up all the circuits. These could very possibly be the last logic circuits we make, because we're upgrading to microprocessors. More modern kind of circuit. Okay, here's all the silver bolts we need. It's actually surprising how much silver you need in these electronics. I hope microprocessors don't use as many. Okay, here, we can start crafting up our MV circuits. This might be the largest recipe of MV circuits that we've ever done. I don't even remember, I did so many last episode. AE2 is going to make this type of stuff much easier. I won't have to maintain any of the machines. I'll probably be passiving a lot of the materials for it, and then I can just wait like 16 seconds for all of my systems to craft up the circuits. But that's when we get AE2, which might not even be this episode, because I'm realizing just how much has to be done. We practically have to get to EV. So I know I don't talk about food very often, but so far I've just been eating garlic and wheat and sometimes sandwiches, but my nutrition has gone down a lot because of that. But I don't want to focus my entire playthrough on food. So I just learned about something in TFC and in real life by extension called hardtack, which would be something that sailors would eat on ships, because it's very, very easy to make. It's literally just flour, salt, water, and it makes a ton of dough here. And it lasts really long. The actual cooked hardtack can last almost 12 years, and then if I put it in a preserves jar, that's going to be longer than the entire playthrough. So what I'm going to do is I'm just going to plant a bunch of wheat right now to make some hardtack, and then I'll also harvest some garlic. But hardtack is probably going to be our food for the rest of the game. But yeah, that's just some other things going on. I should really get back to work on the circuit assembler though. So we're going to need more HV circuits to make the circuit assembler itself, and that's going to need some more RAM and transistors, but I'm pretty sure we already have enough. And I'm only making 2 circuits right now. Quite annoyingly, it needs electrum, and electrum needs silver and gold. Probably one of our least abundant materials. I've used up all of our silver on MV circuits, and gold should be in here. Yeah, we have a decent amount of gold because it's in iron veins. So we're just gonna go over there and mine out that silver mine. I was gonna use an MV miner over here, but that needs a bunch of nickel, and since we're going mining at the silver mine, we might as well go mining for that nickel as well. So in this mine, I was too lazy to replace the roof, which is a pretty dumb reason to just cut a hole in the middle. But this time, we have planks, so I don't have to worry about that. So I've hollowed out the entire Galena mine, and I have discovered, not really discovered, but revisited one of our new mining strategies. Just take the drill, and then support, and then drill, and then support, and then if I want to be really efficient, I can come back around here, because I can do a whole row in between without adding more supports. And this just prevents my drill from caving in blocks that it is breaking like it did in the copper mine, which means we get maximum ore yield. So I've just been doing this the whole way down the Galena mine, and we have tons of silver because of it. The only methods that are better than this are a huge waste of time. Okay, I think we've cleared out half of this ore vein now. Created a huge cavern. I don't think we'll really need to come back again, because what I need to work on instead of stuff like this is a way to generate silver or to bypass silver costs in recipes, which is going to be quite difficult in HV because motors will need electrum wire, which is half silver. Okay, so I might need a better crate for our lead mine because this lead line is wrapping around the chest here. But that is all of the lead we got from that mine, and I have enough supports for the next mine. I'm just going to turn a bunch of Kapok into planks. Okay, so that is our full load of nickel and cobalt. This cobaltite is going to be a great source of arsenic, meaning gallium arsenide is easier than ever. Speaking of which, a bunch of monocrystalline silicon bools here. But all of this diamond, all of this cobaltite and nickel, and all of this lead and silver is a perfect start to this episode, and we can now start working on many different factory things. And I can stick these all in. I don't know how much this weird smelting system can actually handle at a time. Also, weirdly, no one has commented on just how weird my smelting system is. Like, I thought more people would be complaining about it, and you're absolutely right to do so. But, yeah, it's just a really slow conveyor with one fan, because I didn't want to make more fans. Later this episode, we're going to be making coils for the pyrolyze oven, but right now, this stuff is only for motors. Okay, and why we're making all of these motors is for the circuit assembler. For the circuit assembler, we'll need an MV emitter, MV robot arm, and 2 MV conveyor modules. These totaled up need, I think, 7 motors. Very expensive, but luckily we're making 16 right now. And here, another 64 copper nickel wire, 32 aluminum rods, 16 magnetic steel rods, and 32 copper cables to make 16 MV electric motors. And while I'm batch crafting this, I may as well batch craft a bunch of other things. So let's start with some pistons. So extruder molds come in handy again, with small gears being made for really cheap, really fast. We can turn these 6 ingots into 12 rods, and these 18 ingots into 18 plates. And here we go, easy pistons. 6 pistons. And then along with that, we can start working on the actual components, like these 2 conveyor modules. And then the last remotely easy part would be this 1 robot arm. Okay, so the last component we need for the circuit assembler is this MV emitter. Actually, what am I saying? We don't even have the HV circuits yet. I completely overlooked those because we mined the silver and then I forgot about it. And there's our 32 electrum wire, so I can throw that all in. And that's 4, no, I think it's just 2. Yeah, 2 more HV circuits, so I did overcraft these. Doesn't matter though. We have our circuits, and the last thing for real this time is that MV emitter, which isn't actually that bad now. I can get the electrum rods right in here, and I have the wires and flawless emerald I need, along with the MV circuits, so I think I can just craft it right in my inventory now, yes. But with all those components, we can make our circuit assembler, and this is technically, in a way, our first HV machine because it uses HV circuits, though maybe the steel boiler counts. But we don't care about the fact that it uses HV circuits, we care more that it makes HV circuits. This is a really, really good recipe that's one-to-one from microprocessors to microprocessor assemblies, so MV to HV. Microprocessors need plastic circuit boards, which we can easily get. There's 2 valid recipes for us, the PVC version and the polyethylene version. PVC is double, so I'll probably use that since we have so much chlorine. Capacitors we can make, they're really easy. Aluminum, polyethylene. Transistors, we have a red alloy wire, resistors. All we're missing is this CPU chip, which needs light blue lenses. Luckily, we were just at a diamond mine, so we can very easily do that. Interesting thing with diamonds, in normal grade tech, these are really good for tools. By making a diamond block, you can cut it into diamond plates like we're about to do, and then use that for all sorts of tools. And this would normally be the best kind of tool, but this is 4,000 crafting uses, while my red steel wrench is 15,000, so it's just not even close. But if you're playing something that isn't TFG, you should use that recipe once you have a cutting machine. Speaking of the cutting machine, I made a ton of silicon wafers. Okay, so we have our diamond lens, and I can just put this with 4 wafers in here, and it just takes 45 seconds to make a CPU. Okay, and now that we have a CPU wafer, we can cut it up, and I'll work on everything else we need. And now we can make 10 buckets of liquid PVC, which we can solidify into sheets in here. PVC is twice as good for making circuit boards as normal polyethylene, and I might as well do it because it's essentially the same cost. We have so much chlorine. There we go. So we're engraving, actually I think the correct term is etching these PVC sheets, and we're just going to etch them into plastic circuit boards, which with more copper foil can be turned into printed circuit boards, PCBs, and those are used for all of our microprocessors. And there we go, a plastic printed circuit board, and we have a lot more coming. So these are actually way easier than I thought they would be. Then the other thing I'm going to make at the same time are the new capacitors, which are actually just shockingly easy to make. I'll make a stack of them. Okay, first electronic recipe of the day. Here's our capacitors. So our CPU chips are done. Here we go, 32 fine red alloy wire to use all of our transistors, capacitors, resistors, and CPU chips. And we are now making the first microprocessors. These are the best MV circuits, literally. The best part with these is that we have a lossless HV circuit recipe, and what I mean by that is it's a 2-to-2 ratio instead of a 2-to-1 ratio. And by the end of the episode, we might even be getting this EV circuit. That's the goal at least, but I don't know if I can reach it. So the next step towards getting HV power is the pyrolyze oven. Why the pyrolyze oven? Because it is a better coke oven. It can make wood tar, 3.5 buckets per recipe if you include the charcoal, which can be distilled down into benzene, used in the gas turbine as one of the best sources of power until nitrobenzene, which is actually made with benzene anyways. This can get us a reliable source of about 3 amps of HV power with just one pyrolyze oven, unless my math is horrendously wrong, someone will tell me. And this will need about 2 LV extractors, 1 MV distillery, an MV pyrolyze oven, and an HV gas turbine. But right now, our wood supply is failing. I haven't tried to fix this yet because I am really scared. But in a test world, I was able to just right-click the bearing. Really should make a world backup before doing this, but we're fine. So the steam engine never stopped, which is a good sign, that's why we made it. And it shouldn't ever get blocked off by a tree. At one point there was a bunch of items on the ground, maybe it just stopped due to lag reasons. In which case I should get an item vault on here. Oh no. Oh, I'm so glad this thing stopped right now. Currently there's 2 contraptions here. One of them is placed, the other one shouldn't exist. And we are going to fix that by doing this. Why didn't it stop? Oh, relogging also just worked. I'm not complaining. That's laggy, not because of a crash, but instead because it just cut down the largest tree. Okay, there. 150 Kapok logs in there. And I can see if this works because we are now full on sticks, and there's a new stack that has no space. So it'll pass by this funnel, and it's filtered to not work. And it'll pass by this funnel, there's no space for it, and so it goes in there, and it's incinerated. And now we can siphon off of this entire chest and get our pyrolyze system running. Paradoxically, we kind of need the pyrolyze oven and its turbine setup to power that same pyrolyze oven, but what I can do instead is I can get a weak bronze boiler like this and power the entire setup with that, and then it's not leeching off of its own system. So we've only made 1 bronze boiler, but I think making another one will be pretty cheap. There, that's the main block, and then we have the firebox casings already, so I can already start setting this up. I don't know where I'm gonna put it, though. No. No. No, it's too late for that to happen. It's too late in the night. Oh no. The water got to half. If it hit 0, my base would be gone. Someone asked, like, hey, you keep hyping it up, just let the explosion happen. If this thing exploded, most my blast furnace blocks would be gone. Half of this factory would be gone. Most my MV line, definitely the valuable part of it, the circuit assembler, the normal assembler, things like that. Like, these machines would be gone. There would be a crater all the way out to here. The steam engine would be damaged. That's at least my memory of the explosion. They might have nerfed it. Maybe what I was seeing was modified, or just GT&H fun. So yeah, we're not expanding off of this steam engine, because that's way too dangerous. We're just going to use some water wheels. So by waterlogging the source blocks like this, I not only get a more compact system and a cooler looking system, I also get a less annoying system, because I won't just walk into that water. Also, it just looks like they're spinning for no reason, which I like in Minecraft's most realistic mod. Also, new update, don't know if I've mentioned this enough, but you can craft LV casings in your inventory without red and blue steel. Now, for players who've actually played to late game in older versions, you may realize that this is actually really bad because you can't arc furnace the casings, but that's irrelevant to my playthrough, because I never got there anyways. Wait a minute. So it's still there. It's actually worse. I take that back completely. It's actually worse. So I need plastic. Glad that happened after I got plastic and not before. Yeah, because this isn't very useful, or at least it wasn't very useful, I didn't mention this, but we have a new casing recipe. using polyethylene. This works on, yeah, any casing. So we'll have to use liquid polyethylene for these casings forever. Little known fact, you can use casing on cogwheels so that cogwheels in front of them don't affect it, so you can have really compact acceleration systems like this. So yeah, this is actually done practically for once. I could probably do it with less water wheels too, but I want to be safe. So this is the last little bit of casing right here. And that's just another boiler. And I just need to make sure the water is sufficient because we do have significantly less than usual. This is probably the slowest boiler I'll ever make. This is power production to power the power production, if that makes any sense. We're going to move that pyrolyze oven. That's going to get powered by 2 MV turbines. Then we're going to have an MV distillery. And then we're going to have 2 LV extractors, all being just barely possible with this much steam. So, with that said, I should actually take down my old pyrolyze oven. This is where we're gonna get our logs. Wait, no, I did my math completely wrong. This boiler is plenty. Because yeah, it's 2 amps of LV power, not 2 amps of MV power. Yeah, I might stack a pyrolyze oven on top of here. Here's our pyrolyze oven, and now that I think about it, we do actually have all the turbines necessary for this system, because when we took down the old EBF setup, I got all of these LV turbine generators. I'm building a new power plant out of a bunch of recycled materials from late LV. But we have all 4 of these turbine generators with these aluminum pipes. This is producing a constant 4 amps of LV, so we're back in episode 6. But that's plenty for this pyrolyze oven, which doesn't need any fluid input, we just need to get those logs in. And I think we have a spare tin item pipe, so I can immediately start this. So this is going to automatically take our infinite supply of Kapok, and it's going to create ridiculous amounts of wood tar and charcoal. And I mean ridiculous amounts. 16 logs to 20 charcoal. Remember when we put 16 logs in a log pile and get like 6 charcoal? The next step in this benzene factory is going to be a bunch of extractors. We need exactly 4 LV extractors per MV pyrolyze oven. Okay, here, 16 LV motors, 2 LV electric pumps, and there's 4 LV electric pistons, so now we're just missing the trivial components. I actually haven't used this arc furnace glass recipe enough, because this is ridiculous, 1 sand to 2 glass. But here we go. 2 LV extractors. How quickly does this run? Oh, okay. So it is actually only using 4 EU a tick. It is not overclocking. Like, 1 turbine can run 8 extractors. Okay, I can just get as many as I want. Okay, here's 2 more extractors. Pretty easy since I made all of the materials. And now I just need to make the extra LV cables. Okay, these are now making tons of wood tar. Pyrolyze oven is also still running. Here we go, MV distillery. And make 2 pipes to make an MV turbine. For the pipes on this factory, we're going to use small aluminum pipes because they're probably the best ratio for cost to flow rate. Okay, but that's producing wood tar, which is going into this distillery. So every time this finishes a recipe, it produces 1.5 buckets of wood tar and a bunch of charcoal, which we're turning into more wood tar, totaling to 3.5 buckets every 32 seconds in this distillery. And then if I grab my annealed copper wires, then this distillery is now producing a ton of benzene. So of course the last step to HV power is the turbine itself. And this is going to be actually kind of difficult, unlike all the stuff I just did. Because we're going to need our first bit of stainless steel to do that. We're going to need manganese, nickel, iron, and chromium. So nickel and iron, pretty easy. Chromium we have a method for, and might actually have enough spare. And I'm going to have renewable manganese soon. So I might not even go mining for it and instead try to find another way. Okay, so interestingly, because I have so much scheelite, not a lot, but I have a decent amount of scheelite and tungstate, and these can be washed to get manganese, so I'm actually going to do that. 10 seconds per recipe, and we have a 33% chance of getting manganese dust. We only need 8. So actually wasn't too bad after all. We don't need that much manganese or chromium, and the stuff we have sitting around is plenty. Okay, here, we'll put in 8 nickel dust, 3 manganese, 8 chromium, and 8 iron. We do need more manganese, but this is our first stainless steel recipe. And actually, I'm going to take the aluminum out of the blast furnace so that we can run this. Speaking of which, I've been stockpiling so much aluminum. Now we have all of this to spare. I can make anything out of aluminum. Here we go, 9 stainless steel dust. HV, here we come. Oh, and stainless steel's also easier to smelt than silicon. Very funny game. And just 5 more seconds, and we get our first stainless steel ingot. So stainless steel is gonna be the new aluminum. We have to make all of our machine hulls out of stainless steel, but unlike aluminum, this isn't gonna be renewable, cheap, or easy, and chromium will always be a pain in the ass to get. And once I polarize these normal steel rods, I think that's actually everything we need for HV motors. Get all the cables. Note that these are 2x cables now, unlike the motors before them. There we go, 2 HV motors. Properly HV now. Then I also need some gold cable. Gold cable is going to be the main HV cable in crafting recipes, the same way tin was for LV and copper was for MV. I'm a genius. Why am I making an HV steam turbine? So, a bit of a mistake. I was looking at the steam turbine recipe, because I usually just make those. Have never actually made a gas turbine in GregTech before, because my only GregTech experience is Nomi Factory. But actually what we need, instead of those pipes, is an extra circuit and a steel rotor. And I just arc furnace our pipes, so I can put these all in the bender, and we have more than enough stainless steel already. So we're getting kind of modern here. HV machine casing. This might be one of my favorite casings in how it looks, I don't know why. And for our first HV machine hull, we will be using the new recipe using plastic, just to save an ingot. There we go. HV machine hull, and we can immediately turn it into an advanced gas turbine generator 2, even though we got none of the previous versions of it. There we go. Look at the power storage on that. So that is a gas power plant, a very interesting one. I don't think anything like this is used in real life, but in-game it's really good. So we have a gas power plant, kind of, stretching the definition. And this is going to be producing 512 volts, 1 amp. I have to check if it's actually producing enough benzene to do multiple turbines. I don't think it is, but like I said earlier, we can parallel more. And where we're going to send this power is actually the second floor I built last time. I barely flashed this on camera, but basically, while I was smelting all the canthal, I cleaned off the roof, put a bunch of torches up here, and put a staircase, because this is going to be our new floor, and we're going to have all of our HV stuff up here. We're going to use all this diorite cobble we've built up to get a bunch of white diorite bricks to give it a much more modern feel, and also budget cuts. It's cheaper. And then for the supports, on this level we did basalt, and I should probably keep it consistent. Okay, so that's all the frame laid out. Okay, so that's all the walls in place now, and all that's left is the windows and the roof. Okay, final stretch. But that is the roof fully filled in, and this area is now functional. Okay, so there's 2 last things I need to do to finish this area. I need to get all the windows in, just like we did here with the framed trapdoors. And then I also need to get the blue steel lamps, so that the lights never go dark. Oh no, no, that's tragic. I accidentally threw my saw because I had no inventory space. And it hit this chute and now it's gone. Guess I'm using this bronze saw for now. So now I just need to make 192 trapdoors. Doing it from the outside will be way more difficult now. Okay, this is the last window now, and it's fully enclosed. Something I can't find online is if blue and red steel are actually real things. Because when I search it up, all that shows up is some old TFC wikis, an Etho video, a Flurbin video, and my video. So if anyone knows, I would like to know if these are real. By the way, fun fact, we can actually smelt blue and red steel in the blast furnace. It's easier to make than silicon. I will never get over that. I'm actually so mad. Here we go, 32 blue steel being smelted for the first time ever in this blast furnace. It's gonna take as long as Canthal. Oh, that's half an hour. Well, it's 11:40 for me, and I have church in the morning, so I am going to stop, and tomorrow I can finish the top floor. Now that I think about it, we don't really need the blue steel lamps to start using this floor. It's going to be quite dark for a while because the torches will keep going out, but that's fine. So I'm going to start hooking up power to this floor. We're going to start by moving this turbine further up because it's easier to move benzene further than to take the resistance from cables. So I'm just going to make a bunch of small aluminum pipes here. Okay, so now our gas turbine's running, and we're on the second floor. I should actually see how this looks like from a distance. Oh, that's very nice. Oh, and I started this bashing rocks together, collecting sticks from the ground, and now I have all this. This is the most satisfying part of the mod. Like, normal Greg Tech's satisfying enough, but when you add in that I had to go through the entire Stone Age and Bronze Age and everything, it's so much cooler. Also, over here we have like 62 stainless steel, so I can definitely start on a lot of things. Firstly, actually, I want to work on the battery buffer, which is going to be quite an undertaking, but I already made all the gold wire for it. This is crazy. I'm pretty sure we already have most of the stuff for it right now, though. Okay, 2 gold cables, and that'll be another HV machine hull. There we go, high voltage 16x battery buffer. Kind of overkill, but I don't care. So HV actually has some interesting cable logic because silver cables have very little resistance. You have 1 volt loss per block, but it only stores 1 amp per wire, like every other cable we've ever used. But gold actually takes 3 amps per 1x cable, which is crazy. And so I'm often going to be switching between silver and gold wire. In this case, I'm just going to be using silver cable to minimize resistance between the turbines and the battery buffer. But for the actual machine line, it's all going to be gold. Thing is, we don't actually have any batteries, no HP batteries yet. And for now, I only want to get 4 batteries in there because we're going to be replacing everything in the future. So we want 4 large lithium batteries. Now we have so much lithium from clay. So that should be pretty easy compared to previous batteries. We'll need a stack of lithium, and we'll need a ton of lead. We need 9 battery alloy per, so we need 36 battery alloy plates. So then that's 28 lead. I don't know, do we have enough lead for that? Okay, then there's also the gold cable. Gold is going to be a huge problem, and I know how to fix it later. But right now, we're just going to have to eat through all the gold we've amassed from all of the different hematite mines. But here's enough plastic for the rest of the batteries, and I got enough cables as well. So this assembler will make all 3 remaining battery hulls. And we have the lithium. Now all we're missing is time. Okay, 1 lithium battery is done. And I have 2 more hulls here. Oh, and here's a 3rd. Okay, so here's all the remaining batteries, and that will take 240 seconds, 4 minutes. Just that battery is, what, 1.8 million EU? That's crazy. And now that most of the blue steel lamps are done, I can start placing those down, and that floor will be ready. So the HV floor is done. Probably going to be more than the HV floor, but HV will take up a lot because I plan to do gabbro processing here. I'm going to automate plastic later. We're going to have a clean room. We're going to have our AE2 system starting, so there's not a lot of space for other voltage tiers. So this is the HV floor. So unlike all of the tiers before this, we're actually doing power infrastructure first. We now have this battery buffer with 4 large lithium batteries, containing a total of 7.2 million EU, with a gold cable able to handle up to 6 amps right now. Later, we're gonna fill all of this with energium crystals, though, and we'll have 16 amps. That's not now, though. We're gonna make an HV assembler first. An HV assembler will need a total of 4 HV circuits, 1 per robot arm, plus the 2 out here, and then we're also gonna need a bunch of motors. I'm pretty sure we have enough stainless steel already. So 24 stainless steel rods, 14 stainless steel plates. Turn these plates into hulls. But the big problem is these 4 HV circuits. And that's what we spent the start of this episode working on, by getting microprocessors. Now these microprocessor assemblies are very cheap. I think I'll just make 8 of them, and that's gonna need a lot of copper. Luckily I just smelted a bunch. I'm making a sign, and I'm gonna put it on the bender that says 10. Because the circuit is on 10, and I have turned so many things into foil at this point, on accident, that it is actually ridiculous, and I need to stop. This is an intervention on myself. So I'm gonna need 32 capacitors, and because we overcrafted, I should have that. And then we have the RAM, I'm pretty sure we have the fine red alloy wire, so I can start putting these into the circuit assembler. Here we go. The first microprocessor assemblies. Ignore the 2 that are already in there. So I have everything in place now. We can just make the 2 robot arms. And there we go, HV assembler. Our first HV machine. I like the orange text. And now tied with our blast furnace, this is our most expensive machine to run, power-wise. 512 volts. So, to show off the power of this new assembler, we're gonna make some SMD capacitors, because I just used up all of our capacitors. I wish we could use this tantalum recipe over here, that can make 24 at a time, but right now we don't have tantalum. I'm gonna fix that later this episode. But this is really cheap. I could probably just use 1 ingot of polyethylene and half an ingot of aluminum to make 24. So we've only made 1 set of capacitors ever before, but just to compare these, this costed 2 aluminum foil per. So to make the 32 we had before, I would have needed 8 aluminum foil. Now I'm making 24 with just 2 aluminum foil. And it's not even a slow recipe either. So here's some proper electronic components, and we're gonna be using these for everything until, like, LUV. We're gonna have fusion reactors before these are replaced. Probably not, actually. It's still an insane recipe, and it can be improved with tantalum. So once again, I'm in a little bit of a predicament. Do I pivot to make a tantalum factory because you can get it from lava, which we have infinite, or do I continue working towards the original plan, which was an HV macerator? I now have a ton of chromium, and I stockpiled a bunch of manganese over here. So stainless steel's not actually a problem right now, and manganese, the most annoying part of it, actually comes from the tantalum factory, so we're gonna do the tantalum factory first. This factory could have been done last episode, but I decided against it. We can take lava, very small quantity, and just centrifuge it. 4 seconds in an MV centrifuge. The thing we care about is this tantalite, which can be electrolyzed into manganese and tantalum. Tantalum's great for SMD components, and manganese is for the stainless steel, so this is just HV. Another great thing for HV here is this gold. It's a renewable source of gold, which can fix all of our wire problems. Not really. Still need silver. There's a couple other materials we get here, like magnesia, and the sapphire and silicon dioxide are both great sources of oxygen as well. So that will be our next goal. Okay, so I just went to a testing world to figure out what kind of centrifuge we want to use, MV or HV, for our lava factory. So we're going to be using MV centrifuges, and I want to pull off of this line, so we're going to have an MV transformer that transforms down from HV to MV, and then we'll only need 1 amp of HV to supply 4 MV centrifuges. And yes, we're going to need 4 centrifuges if we want a decent amount of gold and tantalum. I already have all the machine hulls for this, and I just need a few more copper cables, and we can already craft up all of these centrifuges. And there's 1, 2, 3, 4 centrifuges. Okay, so all 4 of these are powered already. And then finally, I think I can just get this water wheel spinning, put a large cog wheel here, and there we go, it's pumping out lava. It's kinda limited by the pipe size, but that's not a problem since this processes lava quite slowly. Also, already, I think the probability is off or something, because there's no way it could generate this much this quickly if it was actually as low as the game says. But we already have tantalite and quite a bit of gold. Oh, this is actually really good. Okay, so I was very concerned that this would just not be enough ever, and I'd have to go mining for this type of stuff, but I think we're good. I'm just gonna get a bunch of item pipes and then a storage crate. Here we go. So everything's automatically outputting into here. We already have an ingot worth of gold. And here we go, already 9 tantalite. So I can go down here and electrolyze it to get 2 tantalum. And 2 tantalum doesn't seem like a lot, but we don't really need a lot of tantalum. For example, this is a quarter of an ingot of tantalum, making 24 SMD capacitors. And then here's half an ingot of tantalum making 32 inductors, another half ingot making 32 resistors. These are amazing. With this, just this, I can make a stack of transistors, which is crazy. So that's SMD components, all filled out. And by the way, I would like to point out that it wasn't just editing. This factory was really easy to make. We have all the MV components now. I've got a little bit better with Create. I mean, this routing at the end was a bit bad, but it's looking a lot better now. Okay, so now that we have this HV system put together, it's time that I reevaluate the goal of this episode, because it is just not doable. I looked again at the ME drive recipe, and I'm probably already about 30 minutes into the video at this point. I mean, for me it's been 12 hours, but for an ME drive, we're gonna need these glass cables, which need fluics. In an HV mixer, we're gonna need this titanium, which needs to be put in a vacuum freezer, and that complicates things, because a vacuum freezer needs EV circuits, and it's a whole thing. So, much like trying to get to LV in episode 4, but just getting the infrastructure instead, I'm gonna have to pivot to just getting the clean room and those EV circuits, because those EV circuits allow me to make a vacuum freezer for titanium. That's not to say this video is gonna kind of be a nothing burger, because we just entered HV, and to get this EV circuit, we're gonna actually need to make a clean room. So a clean room is a room that's clean, believe it or not. Basically, you have a very advanced ventilation system to lower the amount of particles in the air by an extreme amount, and it's usually only used for computer manufacturing. And we're gonna build one in GregTech now. And so the clean room main block is gonna need a bunch of filters, it's gonna need rotors, it's gonna need motors. Actually, it's probably less expensive than this assembler we just made. Then it will also need these filter casings. For the smallest clean room, we can just use 8 of these on the roof. Again, pretty simple. It's like a basic MV machine. I just need 8 of them. And then finally, we're gonna need, I think, 40 plascrete. We're gonna need 6.5 buckets of concrete. We're gonna need 270 polyethylene, and we're gonna need 45 steel frame boxes, which is insane. We do not have that much. What I can do is I can keep my brewery right here, and then just use a pump. Actually, yeah, there's a pump already here. Then to automatically input biochaff, I'm gonna put a hopper here, and this should very quickly fill up this entire aluminum drum. Then earlier, I also got a bunch of hydrogen and oxygen in here. We're getting hydrogen from electrolyzing the methane in that drum, and we're getting oxygen from electrolyzing this silicon dioxide. And those are basically the 2 best ways of getting those gases in the entire game. Okay, I've turned all of that hydrogen into hydrogen sulfide, and now we combine that hydrogen sulfide with a ridiculous amount of oxygen, and that will slowly make us all of the sulfuric acid we need. In total, this will make 32 buckets of sulfuric acid, plus the 6 buckets that I already had. And then, with the recipe we're using, we get to recycle half of it. Okay, so we're gonna need to do 12 recipes of concrete. And there we go, that's more than enough concrete. And this brewery just ran out of water, so I'm gonna take all 127 buckets of biomass here, and we're gonna very slowly run that through the distillery. Pumps are very useful for things like this, where you just want to produce a bunch of stuff, batch crafting using fluids. I can just stick the pump onto the top, set it on import, and it will just start producing ethanol, which I don't want to go in yet. Okay, so now we should be making 32 buckets of ethylene, which is really overkill. We don't even need 90 plascrete, and this is enough for like 100 plascrete, so. And everything else is done now. I have the steel just sitting in my inventory. I'm gonna slowly turn it into rods. Okay, can I just comment on something real quick? There's an iron pressure plate here, and this is the recipe they made for it. They need a full spring, which needs at least a long rod, and you need 2 blocks of wrought iron, 4 screws, and some tools. And then look at what they do to the iron door. It's just a wrought iron plate. It's literally cheaper than vanilla. Okay, now that we have this ethylene here, so if you're playing for yourself, I actually don't know if you should automate plastic. Right now, I feel like this big batch of plastic I'm doing is gonna be the largest until I have AE2. And once I have AE2, I can just do fluid auto crafting, and I'll just passive it that way. So here's all 46 frame boxes I need, and I can already start crafting this stuff. So I'll slowly start putting more and more polyethylene in here. The point is, we have plascrete now, and I can start working on the filter casing as well. Oh, then there's the cleanroom block itself that I should also be working on, which needs a bunch of HV stuff, and some more filters. So I'll need this much for stainless steel rotors, I'll need this much for motors, then I'll need that much for hulls, and that's it for stainless steel costs. Uh-oh. I turned an entire machine hull's worth of stainless steel into foil. Now I have to turn it into dust. On another note, I got everything for the filter casings, which means that we finally have a section of the clean room done. Okay, so that's our last bit of ethylene we need for the polyethylene sheets, and we're already very close to being done with plascrete. I could probably start building it already. Okay, this is a very rough structure just because I don't have all the hatches I'm gonna add. Okay, here's another HV machine hull. We have 2 HV motors, and there's the main block of the clean room. So that concludes the main part of clean room crafting. We have all the clean room specific blocks. I can place down the filter casing here, and then put the clean room there, and it says invalid structure because we haven't actually filled it in. But this is the main part of the clean room. Apparently all the buttons have a really dumb recipe that requires pressure plates, which we looked at earlier. Awful recipe. So we can use framed buttons because framed blocks aren't affected by Terraformacraft recipes. I should be using a lot more framed things, like framed chests work a lot like wooden crates, except they're cheaper, but I just kinda forgot. And then I can just put catwalk on this and act like they're catwalk buttons, even though they're not. So this is the last component we need for the clean room. We're getting an MV diode to pass energy through the walls of the clean room. And we're doing it MV because we only have an MV circuit assembler in there. And there we go, the clean room is formed. Now right now it doesn't have any power, so it won't run, but it does say it only needs 32 EU a tick. So I just need an MV turbine and an LV transformer. Okay, there's our transformer. And because I tried to make a steam turbine instead of a gas turbine for the benzene setup, I already had most of the materials for this. And I think that should be powering it now. Oh, there it goes. It's running. It's cleaning it. No more maintenance problem. I probably shouldn't eat in a clean room. That's a bad idea. In real life it would be. In game there's no consequence. But yeah, here we have our MV power, and that gets transformed for powering the clean room. But then we also have the MV diode here. And this means we can get most of our electronic infrastructure into this room. If we get an HV laser engraver, we can start doing phosphorus-based recipes, which for our current circuits will do 4 times as many wafers, and allow some new circuits like SOCs, MPICs, NAND gates. And actually, to make the wafers, you need a cutter in a clean room. But like I've said before, all we really care about is this supercomputer, the microprocessor supercomputer, which we can now make. I'm gonna turn these 4 microprocessors into HV circuits, which is gonna need a bunch of SMD components, actually. Okay, here, we're gonna make some nickel zinc ferrite, which is very useful in inductors, and it's actually the only valid inductor material for SMD inductors. But we don't need a lot, because each batch of SMD inductors only needs 1 ring, and that makes a lot. Actually, let me see this once we're done. Yeah, because we have tantalum, each ring is going to be 32 inductors, so 1 ingot is already enough for 2 whole stacks. Oh, speaking of which, I should probably get all of my tantalum out of the electrolyzer. Here, 28 tantalum. So we're going to turn a bunch of this tantalum into fine wire, because that's used in all of these SMD components. And I mean all of them. We got SMD inductors, SMD resistors, SMD transistors. Those are literally the most important ones. Actually, inductors aren't so important, but... Okay, here. These will be our first SMD inductors. Then we're gonna need capacitors. Now, we already made a bunch of SMD capacitors just to test out this recipe. So that's already done. Red alloy wire is also done here. And I think that's everything. There we go, we're making some more HV circuits. And because we can just make so many SMD components like this will just always be really easy, and we'll rarely have to make new batches of those, because that was actually half the amount I wanted to make, but tantalum just takes a while in the wire mill. And now I think it's about time we move this circuit assembler. We don't really need any other machines in the clean room yet, so I'm just gonna put it here. And the diode isn't working. Oh, did I put it backwards? Yes, I did. Genius. So we're going to be turning 6 HV circuits into 3 EV circuits. Okay, so we'll need 48 fine electrum wire and 48 blue alloy bolts. Something on the to-do list for next time is to get an MV or HV wire mill, because this thing is not it. I'm gonna need a bunch of things next episode. I'm just gonna completely revamp the base. It seems like I have alternating episodes where there's one big progression episode and then one big infrastructure episode and then progression again. And finally, after 2 hours of plastic production, an hour of stainless steel production, an hour of circuit crafting, and so many other things that have led up to this, I can throw all the materials into here, and we can make supercomputers. So in one episode we got reliable HV circuits and then our first EV circuits. I can technically just make a vacuum freezer, start making titanium, and then head into extreme voltage, though I do not have enough power, which is what next time is going to be about. So I said I'd do AE2 in this episode, but there's still quite a bit left to reach that. Why we have these supercomputers is to reach the vacuum freezer, like I just mentioned, and that allows us to cool hot ingots, which are basically any really expensive ingot. So next time, I will probably work on a bit of power before working on the vacuum freezer, getting a reliable source of titanium, and then making the ME drive. And this thing is what we need to reach computerized storage. But unfortunately, that is not today. So thanks for watching, and God bless.